When you choose Auto in Cursor, you're handing model selection over to a routing system. That matters because not every programming task needs the smartest and most expensive model available. Asking an agent to rename a function is very different from asking it to diagnose a race condition across an unfamiliar codebase. So how does Cursor decide which model gets the request? First, we need to separate two parts of the system. The agent harness manages the overall workflow, gathering code, maintaining context, and giving the model tools, applying edits, and returning the result. The model router has a narrower job, deciding which model should handle the current request. So the router chooses the reasoning engine, while the harness gives that engine access to your development environment. According to Cursor's documentation, its router runs a machine learning classifier on each agent's request. That classifier estimates two important properties: the type of task and its complexity. Cursor doesn't publicly document every signal used by this classifier, so we shouldn't pretend to know its exact internal formula. But its output is essentially a routing decision. Does this request need a fast, efficient model, or does it justify using a more capable frontier model? Imagine I ask Cursor to update the name of a variable in two files. The expected change is small, the instructions are specific, and there isn't much ambiguity. Auto can route that request to a faster and less expensive model. Now imagine I say, users that are occasionally being logged out during token refresh. Find the cause, explain the failure sequence, fix it, and add tests. That request involves code-based navigation, debugging, reasoning across multiple files, and several dependent steps. The router can classify it as more complex and send it to a stronger model, like Opus. The important detail is that routing happens per request. Two messages in the same conversation can potentially be handled by different models. The routing decision also depends on the optimization mode you choose. Cursor currently exposes three models: cost, balance, and intelligence. Cost prioritizes reducing token spend. Balance considers intelligence, speed, and cost. It's the middle ground for everyday development. Intelligence favors more capable models for difficult multi-step work. This means Auto is not making decisions in a vacuum. You provide the objective, and the router selects a model under that objective. A useful way to think about this is as a constrained optimization problem. The router wants to minimize some combination of cost and latency while keeping expected answer quality above an acceptable threshold.